Hey, 8th grade. I apologize that on Friday we did not get to the Kahoot in first period. I'm going to fix that on Monday. So, here's our video as promised. Everything we've been doing with Algebra Tiles these past few days are based on this fact. When a positive and a negative come together, they make a zero pair. It's true with individual units, and it's true with unknowns like x, p, and q. Here's the first example from the 4-problem assignment. When I write this equation as a model, I have a positive 1 and negative 5 unknowns I'm calling A on the left side of the equation. On the left side of the equation, I've got positive 7 units and negative 6 unknowns that I'm calling A. In order to solve the problem, I want all of my bars, or unknowns, on one side of the equal sign, and all of the units on the other side of the equal sign. To get there, I'm going to use what's in my key. I'll create zero pairs. I'm going to add the opposite of what I've got. Since I have negative 5a on the left and negative 6a on the right, I'm going to add the opposite of 6a to both sides of my equation to change the number of bars. And I'm going to add the opposite of 1 unit to both sides of the equation as well. Now I'll circle everything that cancels out. Positive 1 and negative 1 make a zero pair. 5 of the positive bars cancel out with 5 of the negative bars, making 5 zero pairs. On the right side, 1 of the negative units cancels with 1 of the positive units. And also on the right side, all of the 6 unknowns cancel as well. Now I'll redraw the model with what's left over. A single positive bar on the left-hand side and 6 positive units on the right-hand side. Here's what that looks like in an equation. We added 6 positive unknowns and 1 negative unit. The positive and negative unit canceled. 5 of the 6 unknowns on the left side canceled. 1 negative unit canceled with 1 positive unit on the right side. And all 6 unknowns canceled on the left side. The result is A equals 6. Here's problem 2. Again, we have 1 positive unit on the left side and 3 negative unknowns we're calling K. On the right side, we've got positive 6 units and 4 negative unknowns. Since I want all of my bars on one side of the equation and all of my units on the other, I'm going to cancel the largest number of bars I can by adding positive 4 unknowns, or positive 4k, to both sides of the equation. Doing so leaves me with exactly 1 positive bar on the left-hand side of the equation, which I'll rewrite now. 1 positive unit and 1 positive unknown remain on the left side, while 6 positive units remain on the right. But I need the bar all by itself, so to cancel the positive unit on the left side with the bar, I'll add its opposite to both sides. The units cancel on the left, and 1 of the units cancels on the right, leaving me with positive k equals positive 5. Here's what that looks like in the equation. I begun by adding 4k to both sides, because I knew that would leave me with positive k on one side of the equation and 0k on the other. And then to get the k all alone, I added 1 negative unit to both the left and right side as well. The positive and negative unit canceled out, leaving positive k on the left and positive 5 on the right. So the final answer is k equals 5. Here's problem 3. Negative 5 units and 1 unknown called x on the left, positive 1 units and 4 unknowns called x on the right. This is where you've got to learn to use your judgment. The goal is to get all the bars on one side of the equation and all the units on the other. Since all my bars are positive and there's only 1 on the left side of the equation, it'll be easiest to get rid of just 1 bar from both sides. The positive and negative bar on the left cancel, and 1 of the 4 positive bars on the right cancels, leaving us with negative 5 units on the left and positive 1 unit with 3 positive unknown units on the right. Since I want all my bars on one side and all my units on the other, I'm going to add an additional -1 unit to both sides. The result is -6 units on the left and positive 3x or positive 3 unknowns on the right. The last step is to match bars to units. I have 3 bars and 6 units. That means 1 positive bar is equal to 2 negative units. Here's what that looks like as an equation. I begun by subtracting a single x from both sides and got -5 equal to 1 plus 3x. Next, I added a negative unit to both sides. The result here was -6 equals positive 3 unknowns, or positive 3x. The last step was to divide both sides into 3 equal groups, the result of which was x equals -2. Here's the last problem on the 4 problem page. We've got -3 units and positive 5 unknowns on the left, and positive 3 unknowns with a single positive unit on the right. Again, we've got to use our judgment. What's going to make it easiest to get all the bars on one side of the equation and all of the units on the other? I'm going to add the opposite of 3b to both sides of the equation. By adding 3 negative bars, I'm able to remove all the positive bars from the right hand side, leaving me with -3 units and 2 unknowns on the left and a single positive unit on the right. I've got my bars on one side, but there are 3 negative units with them. I'd like to get rid of those. To get rid of 3 negative units, I'll add 3 positive units. It's important to remember that whatever you do to one side of the equation, you must do to the other. The positive 3 and the -3 cancel, leaving me with 2 positive unknowns equal to 4 positive units. Again, we'll divide into equal groups. 1 positive bar equals 2 positive units, so my answer is x equals 2. Here's that last example in equation language. I began by subtracting 3b from both sides. Or to say it another way, I began by adding the opposite of 3b to both sides. The result was -3 plus 2b equals +1. Secondly, I added the opposite of -3, which is +3 to both sides. The negative and positive 3 canceled, leaving me with 2b equals +4, because 1 plus 3 is 4. Lastly, I divided the bars and the units into 2 equal groups, for a final answer of b equals 2. Now for the 6 problems I gave you for homework, I said you could drop the modeling. Here's the first problem. I want all my x's on both sides of the equation, so I'll begin by subtracting 3x from both sides. Or to say it another way, adding the opposite of 3x to both sides. The result is 8 plus 3x equals -1. 8 units plus 3 unknowns is equal to the opposite of 1 unit. I've got all my x's on one side. Now I'd like to get all my units onto the other side. Since I've got 8 units added on to the 3 x's, I'll add the opposite of 8 units to both sides. The result is 3x equals -9. The last step is to divide into 3 equal groups. X equals -3. If it helps you on these 6, go ahead and draw the model. If it doesn't help you, leave it behind. If you'd like to see this problem written and solved as a model, here it is. On the back side of the page, I've included problems that require distribution. If you're still having trouble with the problems on the front side of the page, don't worry about 7 through 14. But for those of you who are ready to move on, I want you to be introduced to what you're going to see later on. To handle the parentheses, we take the 4 and multiply it by both things inside. So we could rewrite this as 4 times 2 plus 4 times 3x equals 16 plus 4x. 4 times 2 is 8, plus 4 times 3 is 12, x equals 16 plus 4x. And now we could solve just as before. Here's number 8. Always take the negative with you when you distribute. -2 times 2p plus -2 times 4. -2 times +2 is -4, so the first term is -4p. Again, -2 times 4 is -8, so the second term is -8. You can rewrite your addition of a negative as subtraction if you wish, and then go about solving the problem just as you did on the front side of the paper. I hope this video was helpful. Be sure to bring a device so we can play Kahoot tomorrow if you're in first period. Second period, I'll have something a little bit different planned for you.